This Week in Radio Tech, episode 150, is brought to you by Axia, and the Axia consoles ranging from the new rack and desk to the Radius and IQ, and the fully customizable Axia Element. Visit Axia on the web at axiaaudio.com.
And now, our feature presentation.
TWiRT. It's episode 150, and that means war stories. Tales of radio engineering daring do from up a ladder, up a tower, and up a creek without a battle.
All right, calm down. He says that to everyone.
This calls for immediate discussion.
What's up, Dad?
All your days are belong to us.
From his palatial office of important business,
or in a choice hotel in a distant land,
this is Kirk Harnack.
Chris Tarr and Chris Tobin join me to chat with inventor and AM Directional engineer Mark Mueller.
You're dialed in to This Week in Radio Tech.
Hello and welcome in. It's time for This Week in Radio Tech. I'm Kirk Harnack, your host. I'm delighted to be here. Really glad that you're here because this is the show where we talk about radio technology, audio. We talk about RF, FM, microwave, new and interesting ways of modulation, old ways of modulation, and we talk about some IT stuff too, because radio stations are having to move into the IT world. They have been for some years, and to compete with other services that are on the internet, we got to be there providing content and making it reliable. So welcome into the show. This Week in Radio Tech is brought to you by the folks who are my employer, and that is Axia. Axia Audio on the web at axiaaudio.com. This is the 150th episode, and I'm just amazing that we've made it this far. That's about 3 years worth of shows. I want to introduce you to a couple of my co-hosts for this show. First of all, we have from New York City, the best dressed engineer in radio. It's Chris Tobin. Hey, Chris, how are you?
Hello, Kirk. I'm doing well. I hope you had a good start of the new year and the holiday season treated you well and all that good stuff. And the weather is treating you well there and at home as well. But there's crazy stuff here in the Northeast. I don't know if it's warm, cold. It's 25 degrees outside right now, 25 degrees Fahrenheit outside. It's a little chilly.
Wow.
But it's good.
Yeah. Actually, here in the midsection of the U.S., we spent part of our Christmas in East Tennessee and part of it in Louisville, Kentucky. And when we went to Louisville, that's when the snowstorm came through and dropped, a good 4 inches of snow. But it was great. The kids made snowmen out in my brother-in-law's yard, and we had a great time. And then the drive back, that was a lot of fun too. But yeah, the roads weren't bad. Speaking of roads and snow and cold weather, Chris Tarr is with us from Muckwonago, Wisconsin. Hey, Chris.
Hello there. We don't have a lot of snow up here. By the way, I want to compliment you. I love the way people from the South say Louisville. It's like they've got stuff in their mouth. We went to Louisville.
That's right.
We went to Louisville. Anyway, yes. What's that?
Go ahead.
No. I am Chris, the Geek Jedi. I work at 88.9 Radio Milwaukee. I'm the Director of Operations and Engineering. I also co-founded the website, The Virtual Engineer. I'm a staff writer for Radio Guide magazine. And in my spare time, well, I don't have any.
I've got a story about Louisville for you.
Louisville?
Yeah. See, this old man and woman, they were driving along the interstate, along I-64. And they were headed into Louisville, and there was a sign that said Louisville, like 27 miles. And the old guy says, "Look there, honey, we're about to get into Louisville." And she said, No, I don't think it's Louisville. I think it's Louisville. And he said, No, it's Louisville. It's got an S in there. It's Louisville. Louis and Ville on the end. So I've got a cousin, Louis, and he's Louis. He's not Louis. So they said, well, why don't we stop at the first place that we come to? We're going to stop here pretty soon for lunch anyway, so we'll ask. So they stop, they go to the counter, they place their order, and the woman says, oh, ma'am, and by the way, would you very, very slowly tell my husband exactly how to pronounce the name of where we're at? And the woman leaned over the sign, she said, Burger King.
Nice. Well, I even on the radio, I actually drove through Louisville several years ago, but even like their voice talent and everything for radio stations say that. Like I heard a top of the hour ID and some big voice comes on and Louisville. So that's how I learned how to pronounce it, was listening to the radio as I drove through.
So I was told my video froze. Is it still frozen? Because it looks great leaving here. I mean, the monitor looks great leaving here. So That's a great idea. We'll introduce our guest. We have a guest that I've been wanting to get on the air for a while here. I've known this guy's name for years and didn't know who he was. So we'll do it quickly. Go ahead and take his video as soon as you want to. It's Mark Mueller from Mueller Broadcast Design. Mark is a specialist in AM directional arrays. First of all, welcome in, Mark. How are you?
Oh, I'm fine. Thanks for having me tonight.
Well, good. We're glad you're here. Go ahead.
Oh, that's okay. I just first I thought I was muted, but then I remember I can't hear myself, so we're good.
And Mark, I became familiar with your company, your products, because of the Mueller Subaudible Tone Decoder, and I thought, man, here's one that actually works. Now, tell you what, we're going to get into that later. Tell you what, Mark, to give them a chance to redial me and get my Skype going again, why don't you spend a minute and tell us a little bit about your company and what you do, and go ahead and take a couple minutes and do that.
Okay. I kind of got into the AM directional array business, not really knowing what I was getting myself into, because I just kind of got thrown into it. In 1983, I started working for Bob Jones, who used to practice out of LaGrange, same place I'm at now. I worked for him for about 6 or 7 years. And up to that point, I was mostly an FM and AM non-directional guy, transmitters and that sort of thing. But he took me to Panama City, Florida, plopped me into a 2-tower directional that needed to be fixed, and said, "Okay, fix it." So I kind of learned the business and that part of it kind of by doing more than anything else. I had been building little transmitters and things like that out of old TV sets back when you could actually do that sort of thing since I was a kid. So this was kind of a natural progression for me. But I'm one of those weird guys that actually likes directional antennas. I mean, this is kind of almost like a vacation for me when I'm out on a job site. So
really? Okay.
It's a challenge. It's like everything's different. You never run into the same thing twice. Most of the time, the people, when I show up, are happy to see me. I'm kind of like the fire department. Oh boy, he's here to make it work now. They even happier when I leave, but that's another thing. But it's just, over the last 30 years, I've gotten more and more into it, and as a lot of the old guard has retired, I find myself doing almost 100% directional antennas, and a lot of complicated ones. I mean, multiple station ones. Diplex 3. I've got one that's got 4 stations running on the same set of towers, and it's just it's been an interesting career. I hope and anytime I try to explain to anybody what this actually is, they kind of glaze over. So this is a perfect venue for me.
In fact. It's not a bad idea to explain, since most of our show will be talking about AM directional arrays and some war stories regarding those. But it would be a good idea to take a moment and explain what an AM directional array is and why it even exists. Why would a radio station, an AM station, and hey kids, I know we're talking about old technology here. AM stations have been around since, for almost 100 years now. Why would a radio station need more than one tower, and why would a station want to transmit more power in one direction than another? And I guess I'll start out just by giving my 2 cents worth. Sometimes you if you're an AM radio station and you have the ability indeed to take the power that you're allotted and point it somewhere, like maybe, the city of financial interest, be it New York or Los Angeles or Chicago or some other big population center. If you could optimize the signal that you're sending to cover that population center, well, that might be a good reason to be directional. Now, honestly, you're going to tell me, Mark, if that's even a legal thing you can do if the opportunity is available. But the other reason, the main reason why AM stations, some of them are directional rather than non-directional, is that in order to fit the station in somewhere, in order to make it work such that frequency can transmit at a certain power level from a certain location and not interfere with other existing radio stations, you may have to, what we call, protect those other radio stations. So let's say I'm in Tulsa and I want to put an AM radio station on, and the frequency that I could use would be a station that the same frequency that's on the air, let's say in New York City. Let's say 1010, like 1010 Winds, where Chris Tobin used to work. And in order for me to put a station in Tulsa, I can't really transmit much power toward the direction of New York City from Tulsa, but I can transmit power in other directions, maybe all other directions, or maybe 2 or 3 other directions. So I want to choose a tower site that's located such that I can transmit a lot of power toward the city of financial interest or the population center, and not transmit power toward the cities where I'm not allowed to transmit power to. And to do that, it takes more than one tower to make an array so that the power cancels out in some directions and adds positively in other directions. So I think I kind of covered that, but Mark, fill in the blanks and where I left off.
Well, actually, you did a very good job of explaining it. There's 2 things at work here. One of them is the FCC will only allow certain, a certain amount of power in any direction towards any other station in order to prevent interference. And then there's also that trying to actually put your signal levels, or the highest signal levels, where the people are. So, let's just say that somebody called me and it wants me to do an allocation study that says, I want a radio station in this place. Okay, we can have 200 watts in that direction, 150 watts in this direction, 30 watts in that direction. But in this direction, you can do 10,000 watts. So what we do is put the city in the direction of the 10,000 watts, and then design the antenna system so that it suppresses the signals in the other direction so that they meet the radiation limits or the power limits. And that basically is the process we go through. It's a lot more drawn out than that, because especially on some channels where there could be as many as 150 stations to have to consider, each one of them we have to calculate the power levels that you can have from any particular location transmitter site, and go from there. And then, you also want to make sure that you meet the other requirements for coverage, especially at night. A lot of stations have a lot higher interference levels than others, so we got to make sure that there's enough signal at night to still cover that city. But those are the parameters that we work under. If you were to ask me to, put a radio station, or what can I do from a certain city, that's the process we would go through. Because first thing I ask is, identify where your market is, and then we take it from there.
Mark, are there still to this day, are there new AM radio stations going on the air? And I ask that knowing that I think there's a new multi-tower, pretty high-power AM station in Las Vegas, or in the suburbs of Las Vegas, that went on the air not too long ago. So are there new stations still coming on? Absolutely. Actually, I've done 2 last year. One was in Palm Springs, and the other one was actually a rebuild in actually closer to San Diego. But the Palm Springs one was a brand new one that we put on. Actually, I had an interest in that one on 1200 that was diplexed onto a 5-tower array that was already there, which is a whole nother, that's probably a whole other program, really, how to get more than one AM station directional antenna to work with the other ones that are there. But that one, I've got another one to put on probably in the next 6 months. There's trying to think of how many it's probably been about 8 that I've done over the last 4 or 5 years that are mostly out of the filing window in 2003. Wow. So, and you mentioned filing window. That I think that implies that if you want to put a new station on the air now, you can't just apply for it and expect it to go through the normal process and get it. You've got to wait for it. There's windows of opportunity that the FCC has. They've been doing this for some years now. Yeah, so when Congress decided that they wanted to make some money off of broadcast licenses, that's when this started. And there are auction filing windows where you basically file your intent to file and participate in the auction. If nobody conflicts with anything that you file, then you pretty much get it automatically if you meet the rest of the rules. But yeah, that last window was 2003, and I don't know when the next one's coming for AM, but it'll probably be in the next year or so. They've just about processed through all of the mutually exclusive groups that were created by that. There was an opportunity in 2005 to disconnect from a lot of these big, long chains of stations. That those are the ones that I've been working on for the clients that I did the engineering for. Hey, this is a War Stories episode of This Week in Radio Tech. And so Chris Tobin and Chris Tarr, I hope you're working on your contribution, your war story for this episode. And if we could possibly keep it on the subject in the domain of AM directionals, that would be pretty interesting. Chris Tobin, anything you might foreshadow for your story?
Well, I'd say keep it at AM directionals. Ooh. Well, yeah, I did. Yeah, it was a 2-tower directional I had. No, I'm sorry, it was 3. 3 towers. We had a little incident take place.
All right.
With little animals getting into the ATUs. Or I guess they should be called line tuning units, but in the antenna tuning units at the base of the tower. And then along with that was some other stuff.
Keep your story. I just wanted to make sure you were ready because with a story. How about Chris Tarr? I'm not sure that Chris has as much AM directional experience. Chris?
No, I had a 5-tower up in Hales Corners there.
So that's right. 5-tower. Yeah. Okay. Well,
I have a couple. I can pull one out. No problem.
Oh, good deal. All right. Well, we're talking to Mark Mueller on This Week in Radio Tech. Hey, let's delve real quickly, Mark, before we get into your first war story about some engineering daring do at a directional. Tell us a little bit about this, how I came to know you, and that was through the Subaudible Tone Decoder. And for years, radio networks, and maybe a few still do, when you had syndicated programming, the way that the syndicator would tell its affiliates to break away for a commercial or rejoin after a commercial or play an ID or a liner was through these tones that are known as subaudible tones. And typically these were at 25 hertz and 35 hertz. Now, these are easily filtered out of the audio that's going to the transmitter site. So we didn't have to, although not everyone did that. And so I even had some shows or some stations that you could hear the flutter on the air when the Spot's going to come along now. But we had to have decoders at the studio to decode these 25, 35 hertz tones and turn them into contact closures that we could actually do something with, like send to the automation system. And I swear, I tried every tone decoder on the market, and they all worked fine if the audio was just exactly right going into it. And of course, there was no standard for how loud should the 25 hertz tone be injected into the show, into the syndicated show audio. So you might have some shows where the tone was as loud as the show, or you might have other shows where the tone was 10 or 15 dB down. So somehow somebody said, well, try this Mueller tone decoder. And I did. And I was in a situation where I had multiple different networks that it sure would be a lot easier if I could just use one tone decoder for all of them. Now, that wasn't always practical, but sometimes you'd have a single satellite receiver that would, by the way, the solution that we were told was, well, buy a tone decoder for each show, each network that you're receiving. Well, that works, except for now we have satellite receivers that have, the same output gives you 4 different shows from different content providers, and the tones were all over the place there. So that wasn't a real solution. I had to find the tone decoder that actually worked over a wide range of audio levels and subaudible tone injection levels. If you've ever been a radio station engineer and dealt with this, you know the frustration I'm talking about. And along came this Mueller tone decoder, and by golly, it worked. Mark, how did that happen?
That was actually it was an outgrowth of a directional antenna project. Believe it or not. I was down in Florida, outside of Tampa, and I was working on a 6-tower directional, and we were waiting for the tower crew to get done. Working, as happens, usually everything happens at once on one of these things. So we get 2 guys up on a tower, and we're waiting for them to get down so we could start tuning. And I was sitting with the station owner, and he had the same problem you were talking about. He says, I can't find anything that works. He says, can you build one? I was like, well, I can try. I can see what I've got, what I can come up with. So I was sitting there, and I just I had gotten a couple of the circuit cookbooks for filters and things like that. I couldn't find anything that I really liked, and I'm looking at this, and I say, what this thing really needs is something that once it hits the threshold, it really doesn't care anymore. You can't overdrive it. You can't do anything like that. So that was the genesis of it, and the decoder in that box is actually a little oscillator circuit. It was sitting there, maybe about 4 or 5 dB under oscillation, and until it saw something that it was tuned to, then it would just go flat out to the rails. So, and then that was detected and, went through a time delay. and the tone decoder would output, a quarter of a second relay closure, and off you'd go. So I built one, and I sent it down to him, and he said, I just talked to the network, and the network wants you to make 50 of these. It was kind of an accidental business, but because I don't usually, I'm an RF guy, I'm not usually that much of an audio guy, but there was a need there, definitely a need there, and we did quite a few of them. I think we sold somewhere around 25 or 2,600 of those things, and they were all made right here in this office. My wife stuffed circuit boards and soldered, and I put the rest of them together and tuned them, and out they went.
Now, Mark, I want to make sure I understand your description of how this thing worked that you said just a moment ago. I thought these things typically worked. You'd have a couple resonant circuits, and if they would resonate from the incoming tone, then you get a closure, or they have some kind of a pulse counter or something like that. But you said you had a couple of oscillators in there. I guess one at 25 and one at 35, and they weren't quite oscillating, but just giving a little kick at the right frequency, they would.
Yeah, it's a single-stage filter, basically, or single-stage circuit that is only about 3 hertz wide. And it was sitting about 6 dB under oscillation. As soon as it got something up to the right levels, you consider watching on the scope, the thing would jump up. And I had it set so that it's a 12-volt bipolar power supply. It would trigger at about 10 volts. And, and then after that, you could put more and more level into it, and it would just clip more and more. But the output detection didn't really care because it was doing that anyway.
And this seems like a novel design, or is this a circuit or a design that's used in other things?
I really don't know. I didn't do much research beyond that. It was basically the basic idea came out of it might even been one of Don Lancaster's circuit cookbook type things. Yeah. And I just looked at it, well, I'll try this, because I tried phase lock loops, and they're too slow. I mean, they would take 70 or 80 cycles before the thing would really lock in, and at 25 hertz, now you're 4 seconds out. So and it just didn't see, and all the tone decoders up to that point had been adapted from the old reel-to-reel automation decoders, which expected -7 tones, and that was it. There was no such thing as a input range. But the prototype ones that I sent out to get tested at radio stations, they could do about 12 to 15 dB tone variations without having to be reset for the input levels. And it had a plus 24 clip point, which also helped a lot.
I seem to recall you had a pretty easy method of setting the input level just with program audio. Was there an LED that flashed or something?
Yeah, it was in the box. I got some people that asked, hey, can we put this on the outside? I said, do you really want to be adjusting that? I mean, it should be one thing, take 4 screws off, adjust it so it flashes red with programming and is green most of the time, put the lid back on and put it back in the rack. And that's what most of them did. I still get, every once in a while, somebody will call up and say, hey, do you still service these things? And I said, sure, send them back. But most of them come back, and they're pretty much still set where they were in 1993 when the first ones went. Excuse me, when it went out. First ones went out in '89. So, but the current design that most of them sold were circuit board revision in '95 to get balanced output for it.
Yeah. Wow. I guess I bought some in the mid to late '90s and used them at several AM stations, mostly my own station in Cleveland, Mississippi. Hey, Chris Tobin, you were involved with network audio distribution. Did you get to use any of these Mueller boxes?
Oh, absolutely. Oh yeah, we used a lot of those when we did a lot of our replays for various shows. I remember one show in particular. Let's see, we did the replays for Bill O'Reilly on the network I worked for, and we used the boxes. They were very reliable. They did exactly what they're supposed to do, and you can't beat that. So I used them there. I used them at the radio stations I worked at for network syndication we grabbed, and again, there were plenty of others out there. Some of you know they were in those card cages, those types, and that the Mueller box was the only one that worked reliably every time.
Well, the other thing that was kind of unique about it is that there was no actual filter in that box for the audio. We reinserted the audio 180 degrees out of phase from the detector, and it just canceled the tone out, which was nice because it was a straight through audio path at that. And actually, WFMT had specified those for their Beethoven network because you didn't have to have one in both sides of the program line to avoid screwing up the phase and frequency response.
It was an excellent design. It worked well, and I know a lot of folks that swear by them.
Hey, Mark, somebody in the chat room, Mike Phillips, asks if there's a schematic of this box online.
Yes, it's MuellerBroadcastDesign.com. Look under products, and it's all the documentation's right there. MuellerBroadcastDesign.com, and we'll put that in the show notes. It's on the little banner next time it comes up. Should be on there. It's MuellerBroadcastDesign.com, all one word.
Okay, cool. All right. And Chris Tarr, you got to use one or two of these boxes yourself in an automation system. That's typically where they work, to automate programs. Yeah.
Well, I actually saw one in a reel-to-reel automation system where I take the tone off the reels and actually trigger them. Just kind of an aftermarket repair. This is an automation system, an old one, I believe IGM or something like that probably should have been retired years and years before it was. But I'll tell you, you go to pretty much any small AM station around the Midwest, that they ran any kind of satellite programming in the 90s, and you're going to find one of those boxes. I run into them still, they may not be in use anymore, but still sitting in the rack, very reliable boxes.
I think it's so cool to talk to the inventor of something. But before he passed away, we had Steve Church on this show, who invented a much better way to do telephone hybrids. We've had Bob Orban on the show. We've had Frank Foti. We need to get Leif Clayson was on the show for a brief segment. We need to get him back on for a whole show. Cornelius Gould. These are some Telos guys. We've had Joe Talbot, who's done a lot of work in voice over IP telephony. You've had Tom Hartnett from Comrex on the show. And so it's really good to get inventors, guys who have put something together and made something work that didn't used to work before, or what didn't even exist.
Not only that, but with Mark, as an engineer too, there are a lot of places that I go and do some work on that Mark actually either built or completely redesigned. So it's kind of funny because Mark and I know each other, and 2 months ago, I guess we're kind of getting into a war story here. I went to a site that he actually did a lot of work on, and it was great because it was really easy to do what I needed to do. But it's kind of funny because you see a lot of those traces as well, not only the boxes that he's designed, but also a lot of these, a lot of the AM stations in the area Mark has done a lot of work on, because as he said earlier, not many guys left who can do what Mark does. And I actually had some fun with Mark once doing some radials for him and or doing some monitor points for him and some things when he was doing some work. So it's interesting how small the world is, and it's interesting to have these guys on to talk to them.
Let's jump into a war story here now, Mark. With all this work you do, around the country. Well, first of all, it must have been amazing learning under Bob Jones. This is a name. This is a guy who's pretty famous in the radio broadcast world, especially AM directionals. Yeah, and he's the guy that turned you on to being interested in AM directionals and learning about what goes on there. So maybe I don't know. I don't know where you want to start, Mark, but if you want to tell us a story from early in the beginning, or even something recent, why don't you take it away and teach us something by way of a story?
Okay. Back in 1983 is when I started doing this. I've almost been doing it here for 30 years, which is kind of scary in its own right. But the one of the first jobs that I actually did on my own was a little 3-tower, 90-degree spaced, pretty much textbook. Simple directional antenna, if there is such a thing. But I got there, tuned it all up. Everything looks fine, and the antenna monitor readings are completely wrong. I mean, completely. The phases aren't even close. We're talking 90, 100 degrees off on both towers. Like this is not possible. And I'm sitting there scratching my head, trying to figure out what the heck's going on. So we fight and get the thing back in, finally get it tuned right, go out, read the monitor points, and they're like 80 times what they're supposed to be. And it's like, well, this can't be right either. So I go up and I'm looking. It's like, well, I'm just going to go take some other, readings, what we usually call a cross radial proof kind of thing, where you just drive a circle around, stop every 10 degrees or so, and see what the thing, kind of get an idea what's really going on. And in the direction of the major lobe, there's like nulls. And I thought, this isn't possible either. So got back, and I realized when I got back that two things had happened. One of them was, and I'm not going to get on the people in Quincy too much, but they had built the ATU panels backwards. The North Tower was actually the South Tower, and the South Tower was actually the North Tower. And labeled as such. And the configuration was the center tower was actually where, you know, in the middle, and there was equal transmission lines to the North and South Tower. So everything worked electrically, but totally didn't work pattern-wise. And the second thing was they had mounted the transformer for the TCT for the center tower, which was the reference tower, backwards.
Yeah.
So not only did I have a 180-degree phase error in it, it's also pointing the wrong direction. So this was the first one I ever did by myself. So at this point, you know, I'm thinking, well, you know, maybe running that hot dog stand isn't such a bad idea after all. But we figured out finally figured out what was going on. Spent a day swapping parts, and luckily it was only just capacitors that had to switch the sense of the two networks. So leading to lagging and lagging to leading. But and then everything worked fine after that. But I mean, these are the things that they don't teach you in the book. These are the things that also kind of prime you to when I walk into an array for the first time, I look around quite a bit to see what's going on. And just kind of to branch off of that one, about 6 years later, I was actually, some of you may be familiar with the WLQV. It's 1500 in Detroit, which is a 9-tower day, or was a 9-tower day and 12-tower night. The daytime was 50 kilowatts.
I heard about this.
And the nighttime was 5 into this 12-tower array. And I drive up for the first time. I going up, and had little counterpoise type screens, elevated screens around the towers. And I'm walking up past the building, so I said, "Oh, something's up on one of those counterpoises." And I look up, and there's this. Let's just put it this way: it was a partial squirrel jumping onto the tower, and didn't quite make it before the tower came and met the squirrel.
It has ceased to be.
Yeah. So that you know, you always talk about keeping one hand in your pocket when you're around something live. I think I spent the first 2 days around that one with both hands in my pocket.
Oh.
So there are things you learn, like I said, that are not in the book, but that's a couple. And actually, WLQV was a couple of other interesting stories, but I'll let somebody else tell one now.
Well, you know what? We actually do need to take a quick break for our sponsor, make that part of the show here. So let's do that. Hey, if you are listening or watching, this is This Week in Radio Tech. It's a weekly podcast where we talk about radio technology, and we try to get interesting guests on. We sure have one this time. It's Mark Mueller of Mueller Broadcast Design, and you'll find him on the web at MuellerBroadcastDesign.com. I hope I got that right. Let's see. Our show is brought to you by Axia Audio. They happen to be my employer, so glad they are. And Chris Tarr is a customer of Axia Audio. Chris, are you with us?
I am. I'm right here.
The radio station that you're working at now already has some Axia gear. In fact, it was spec'd out a few years ago. A mutual friend of ours named, I think a lot of folks know him, a guy named Skip Peasy, recommended that that the station look at some Axia gear. They did, and they liked what they saw, and they put it in. Chris, tell us how they're outfitted there. Axia, by the way, is, it's audio over IP. It's IP audio consoles, so they're all connected together with Ethernet and a Cisco switch. We've worked very hard to get the latency to be very low and the reliability to be very high and the flexibility to be at just like a super maximum. Chris, tell us what you got there at your station.
Well, we have two element consoles. We have several mic nodes. We have several GPIO nodes. We have several digital and analog nodes as well, which puts all the audio out onto the network. I can tell you that the equipment went in, I believe it was 2007, and we had one switch go bad, so now we keep a spare switch. So that's the only failure that it's had. I can tell you my own war story with an Axia, which was actually great. When I first got there, one of the complaints was there was no mic processing on the microphones. They were very dry, and it was originally designed. The station, public radio, a lot of speaking. Now it's a little more music oriented, so they want a little punch. And I went in and I said to myself, I know that the Axia has some built-in audio processing. I've heard that before. So without needing the manual, I was able to dive in, log into the web interface of the Element console, and I was able to set up microphone processing. Set up the ability to do that. Then went into the studio and tuned up the mic processing right on the console. And I'll tell you, that was fantastic. Not only was it easy to do, but it sounded really good too. I was a little concerned because you come from the world of outboard mic processing, and you go, well, what can this do that. But it was real easy to set up. Took me just a couple of minutes, and the results have been great. So for a guy who really didn't have a lot of work with Axia beforehand, I kind of was able to dive in and really get my head around it pretty quickly. It's set up that easy.
Well, cool. If you're interested in getting an Axia audio console or using Axia technology to solve a problem around the radio station, for example, we've got a friend in the radio business. Bob Newberry is an engineer in Birmingham, Alabama. Now, he had just put in a new Logitech console system throughout his Clear Channel facility there, but he wanted a backup STL system between the studio and the transmitter. So Bob got a couple of Axia nodes. These turn audio into live wire, since the rest of his plant was not live wire. And then he got a good quality carrier class IP radio, and that carries these Axia IP audio streams from the studio to the transmitter, carries some streams back too for monitoring. And by the way, his transmitter site has 2 HD transmitters, so he's got a total of 4 stereos to carry in that direction and 4 to bring back for monitoring. Plus, he also uses this IP radio to do offsite backups, security camera monitor the transmitter site, and a few other things. Gives him a dial tone out there with a VoIP phone. And now what was going to be the backup STL is actually now his main STL. He says it sounds better than our other linear STL system. And he switched it for me. I believe him. It does sound better. So there's lots of uses for Axia, from a simple snake to just a routing system. Axia plays well with other brands of consoles and existing infrastructure. Or you can just, replace everything with Axia, consoles and everything. Yeah, Chris.
Can I tell you one other thing that I really love? By the way, we're as part of our move, I'm actually buying more Axia gear for the rest of our studios. But one of the things I love is the Pathfinder software, which is, I believe, an optional piece of software that you have that's essentially a software router. And I was actually out at a remote, and the guy in the studio was having a hard time bringing up one of the sources and configuring it. So I was able to log into my desktop, bring up Pathfinder, couple of clicks, and set it all up, and it was done.
I love it. That's great. Well, if you like more information about Axia, the line of consoles starting down at about $5,000 for a rack or desk console, and going on up to the Element console, which can, if you want a great big one that does lots of stuff, you can spend a lot of money if you want to. But it's all IP audio. Go to the website axiaaudio.com. That's AXIA audio, axiaaudio.com. Check it out. Tell them old Kirk Harnack sent you. All right. We're continuing with This Week in Radio Tech, and our episode number 150, War Stories. Mark Mueller is our guest, and we were just about to get into a war story. I'm sorry, I forgot where we were going to go to. We're going to try to get one out of Chris Tarr or Chris Tobin at this point.
One of us. You do Chris Tarr if you want.
Okay, Chris Tarr. War story, man.
I've got a real quick one, and then actually I got 2 real quick ones because they're sort of related. The first one is actually a non-directional AM, but it was funny because this was just recently, and it was a site that Mark worked on. And, I had mentioned that I was going there, and Mark had said, oh, yeah, I remember climbing the ladder with a bunch of gear on. And I kind of laughed. I'd actually never been up there. I was like, yeah, I bet that was tough. I get out there, and this thing is this rusty old narrow ladder hanging off the side of a building, because the tower is actually on the roof of a building. The AM tower is, and you have to go out onto this graded fire escape, then off of this very narrow metal ladder, climbing the side of the building, then up over the top onto the roof. Now, I'm not a small guy, so trying to climb this ladder, as this thing kind of rattles around, and then get up there get my legs over and around the top of this thing. It was a lot of work and scary as heck. And, so I get back, and Mark actually mentioned, so what'd you think? And I was like, yeah, I'm not going to be climbing that ladder ever again. Because you're standing up there and you look down, and all you see is from 5 or 6 floors up, all you see is the ground, because it's all grading. And you have to actually get your body up over the top swing your feet around and get them onto this narrow ladder. It was the scariest thing. Because I had to go up and change the tuning a little bit. We had put a new transmitter in. And I'm like, that's a one-off project because I am not going back up there ever again. So it was a little Mark story there. But a directional antenna, I have the 5-tower directional antenna in Hales Corners. And, one time, I was checking the antenna monitor, and everything was just way off. And the same kind of thing like Mark said, it's like, it is just not right. So, I resisted the urge to twist a bunch of knobs and went out and checked the monitor points. Monitor points looked okay. I'm like, I don't get it. I get back and I look and, I check the sample lines and everything's connected well, and I didn't see any breaks in the line. Start scratching my head, and I took binoculars and looked up at the loops. Everything looked great. I could not figure out what the deal was. So, in fact, I even got a different antenna monitor and tried that. Same result, bad readings. So like this can't be right. Base currents look good. It's obviously a monitor system. So I call the tower climber to come out. He climbs up, checks all the sample loops, gets to the fourth one, climbs up there, puts his hand on it, and the wire just falls right out.
Oh.
And I hear him yell down, "I think I got your problem right here." And he's got the thing dangling out. Apparently the fittings had just corroded out. Yeah. And the cable broke loose, and intermittently it would work. We'd get readings for a little bit, and then they'd go wild again, and then it'd settle down and go wild again. Well, it was just this cable just barely making contact, and he just brushed it as he was coming up to grab it, and it just fell right out. So make the repair, everything looked good, and it was a great teaching story, because a teaching moment is, don't start twisting the knobs when things don't look right. Because that was obviously, my first kind of gut feeling was, ooh, I better, twiddle and get this back in. And I stopped for a minute and went, well, wait a minute. That doesn't make a lot of sense. If you have to go twisting the knobs, something's wrong. So let's figure out what that is first. So, that was the moral of the story.
That's a really good point. And I experienced the same feeling with directionals myself. Don't just go turning a knob. Mark, when you approach a directional that's out of tolerance, how do you get that notion? Well, okay, we can turn this and turn this and turn this, bring it back in. And when you say, nah, that's too much, let's go find the problem.
Well, a lot of times the transmitter will tell you kind of where to look, because if it's really as far out as what Chris was talking about, the reflected power will be off, the common point will be off, something else that it will be reflected. I mean, the problem will be reflected in some other parameter. And in that case, I bet he was looking at a transmitter that was very happy, which is also very curious in that situation. But there's because these are very old, it's a very old technology that's mostly just plumbing and with some capacitors thrown in. There's very little that can really go wrong, but that also means you have very little, it's not like troubleshooting a circuit board where there's 100 parts on there. Sometimes you're only looking at 3 parts between you and the transmitter. I mean, you and the tower. Yeah. So that's usually the place to start. And I always look at the most susceptible part of the array, which is the part that's sitting under that big piece of steel that acts like a lightning attractor. And check capacitor values, check to make sure that the coil taps are actually there and not vaporized or something like that. Because some of the array designs, it's just you're just shorting out turns. You're not actually tapping the coil, just on a series circuit. There's 4 or 5 turns that are shorted out maybe, and if you lose the tap, it just changes the value. It doesn't disconnect it, which can cause exactly the kind of thing that the parameters shift, but not enough to really upset everything. So that's the first thing. A good visual inspection is always the first thing to do, but I always start out at the towers.
Oh, good point. Good point. Hey, Mark, I want to save your last story for last. If you come up with one, I hope you got another one to tell us. Chris Tobin, you took care of some AM directionals there for a while. What you got in store?
Oh yes,
for us?
yes. Well, I had a two-tower directional AM directional 10 kilowatt, and one morning I had a phone call from the morning host. He said, "Hey, the readings look really funky. I'm hearing popping on the air, the clicking in the monitor." I'm like, "Oh, great!" So dial up the radio at the house. Sure enough, I hear what sounds like the carrier going up and down, but very quickly, almost like a foldback condition. When the towers ice up during the winter and the transmitter doesn't want to turn off completely, it just tries to fold back in power to minimize the SWR. But the problem was this was a summer day, so we didn't have icing conditions to warrant this noise. So I drove out to the transmitter site. As I'm driving up to the property, I'm looking at the towers. Everything up top looks fine, from top down and around. Quick cursory look. Then all of a sudden I notice that it's mid-morning and I'm seeing what it looks like. It might appear as fog or mist at the base of one of the towers. And I said, it's too warm and sunny to be fog at this hour of the day. Let's drive up, take a look-see. Sure enough, the grass is starting to burn, and the ground is arcing, and I'm like hearing the popping sounds at the base of the tower. Now, mind you, it's two self-supporting towers. They're insulated from the ground, so they're sitting on porcelain insulators. And to connect the transmission line to the tower is traditionally a copper tube with a clamp. And that clamp, the junction point of the copper tube and the clamp apparently eroded over time, and it started to move inside the clamp. So the tubing wasn't making proper connection. So, a good couple of amps of RF was trying to make its way across an air gap and created all kinds of strange anomalies with the RF.
Yeah.
To the point where the ground system was getting RF back into it, so it was causing a burning sensation for the grass. Literally, there was smoke coming out. It wasn't on fire, no flames, just smoke. Maybe the moisture in the ground being dried out from the excessive heat. So that made for an interesting moment. I open up the doghouse, so the ATU, to go inside to see what else is going on, and I find at the floor what appeared to be a layer of bugs, insects. All the RF and I guess the arcing or whatever else was attracting the bugs to the coils. So not only was I getting a poor connection at the base of the tower, but all of my tuning, the coils were getting full of spiders, flies, you name it. It was just a mess. Shut down. We switched to a single tower, non-directional, low power. That tower went dark, so to speak. No, it wasn't energized. Cleaned everything out. Fixed the clamp, put a new clamp in. Powered it back up. Everything was where it should be. No need to turn knobs. Monitor points where they should be. Everything was perfect. Thank goodness. But it was the strangest looking thing to see insect carcasses, I guess you'd say, or bodies at the bottom on the floor. I mean, thick. Take a ruler and you just push it into the mess. You had about a quarter of an inch of just bugs, a layer of bugs. So there's probably something to RF, heat, whatever, brought them out. But the grass smoke coming out of the soil was even more fun. So it's one of those things you just never expect. But I didn't have the urge to turn knobs and do anything else. The first thing I did was a visual inspection. So to go with Chris and Mark, if you have a directional, try to stay away from the phaser cabinet and tuning anything until you've gone through all the other 2 or 3 components between the antenna and the transmitter.
Wow, and really not an untypical story. That's the kind of thing that we find a lot, and hence the visual inspection is so necessary. All right, well, we're gonna wrap up our show by having Mark tell us regale us with another war story about AM directionals or two.
Well, I could kind of give you a quick greatest hits.
Oh, please, yeah.
A lot of times, I'll try to do this quickly, but a lot of times you'll have situations where it's not easy to drive between monitor points or the measurement points on an antenna proof. And before the FCC reduced the requirements for how many points you had to make, I mean, it was not unusual to go out and have to read 800 points, in each pattern to get the documentation necessary to get the station licensed. And oftentimes we would use helicopters for that. Just because, driving through mountains, especially out west, or, across bodies of water. And one time I was taking measurements, and I'm looking at the ground because we're visually navigating. I'm looking at topographic maps, and when we fly over something, I take a reading. And I noticed that we kept kind of losing altitude and drifting over, and I get on the intercom and say, okay, could you go over, to the left a little bit, maybe up about 100 feet, and it's kept happening. And then one time I didn't get any response back from the helicopter pilot, and I look over, and the guy's sound asleep.
Uh-oh.
We're going along at 60 miles an hour, about 300 feet off the ground, and the guy I could tell he wasn't just slumped over. But at this point, I don't want to poke him. because that means, we could do one of two things: either power dive or go straight up, because he's leaning on the stick. So I kept going on the intercom. It's like, okay, he finally goes. I say, well, we need to go up a little bit. Oh yeah, okay. Oh, I was out partying all night last night. Sorry about that.
Oh gosh.
So that's one. Another one is the at WLQV I was talking about. 50 kilowatts does weird things in a 9-tower phaser. And one time after we rebuilt some of the stuff, turned it on, had an RCA ampliphase transmitter, which is perfectly capable of doing 100 kilowatts carrier if the phase in the exciter gets wrong.
Oh, yeah.
And we actually generated a plasma arm inside this little phaser room.
Oh, what?
A arm of plasma. It started arcing, and this orange arm came out and got up against the screen and went, and then the transmitter tripped off. Unfortunately, I was standing right on the other side of the screen, and that was one of those ones at 3 o'clock in the morning, wakes you up immediately. And I looked at the engineer. The engineer looked at me, and I said, I think we're done tonight. I don't think either one of us got to sleep after that. But I mean, this was Dr. Frankenstein's lab here for about 5 seconds.
Ooh.
But it's another one of those times when you learn to really respect what we deal with. It's a lot of the solid state stuff now seems like it's just like working on a little two-way radio set, but you can still get some serious damage to you or anything else if you're not paying attention to what you're doing.
Well, 50 kilowatts is 50 kilowatts. It doesn't matter if it comes from an ampliphase or a Nautel, right?
Oh yeah, and those Nautels, I mean, they don't mind putting out 100 kilowatts or 50 kilowatts carrier as long as they get a load that they like. So it's not quite as bad as it used to be because you're much less likely to have issues with the transmitter. But the other little funny thing was back to the tone decoders. I used to get phone calls. I get about I'd come into the office and there'd be like 15 phone calls on the answering machine. They'd all be people complaining about my tone decoder's not working. Please call me. And I would start making phone calls back, and I said, okay, what network are you on? And every single one of them would be on the same network. And I would then say, what did they tell you? Well, nothing's ever wrong at the network, so they're never going to say it's wrong. But I would call them up and then say, you know what? This is Mark Mueller, Mueller Broadcast Design. I build a tone decoder that your affiliates use, and they're all having problems. Could you please go check your encoder? And they said, well, there's nothing wrong here. So, well, that's odd because 20 of these units all failed at exactly the same time, spread out all over the country. So you might want to actually go take a look. And usually that would get it fixed.
But by the way, I can't speak for any network that maybe our co-host Mr. Tobin has worked for. I'm sure he was customer centric. But I got to tell you, my partner in our radio stations is a guy named Larry Fuss, and Larry's the kind of guy that will call and complain to the network once he's proven to himself that the problem's not his. And he gets he would always get the short shrift from networks. Nothing's wrong here. No, all our breaks were on time. No, you were actually 2 minutes over what your pie chart says, and it messed up our automation. And the only network he said that he ever got a positive response, really? Okay, we'll go check that out. We have a complete log. Was the WROR network, where Tom Ray, who's not here tonight, but where Tom Ray works. So I'm just delighted to have Tom Ray with us on most evenings where, he's customer service oriented. Chris, did you ever field calls from affiliates?
Oh, yes. One of my responsibilities at two of the networks I worked for, actually three of the networks, was affiliates and customer service. And I used to tell the guys at Network Ops, the job is to never say no. You'll find somebody who can get you an answer, and thank you very much for being diligent and letting us know we may have a problem. And it took a while. It took about 6 to 8 months for the folks at Network Ops to learn that practice, because you're right. The line always was, it's not at our end, it's your end. And I was an affiliate for many a network for many a year, so I used to tell the guys at Network Ops, look, I was at the other end. I know exactly what you guys used to say to everyone. We don't do that anymore. So we had a lot of calls. And a lot of times it was human error, real simple. And the hardest part is when you're doing network shows that are not originating from your facility, and you have to bring it in from one place, turn it around and put up on the bird or the satellite. There's always something that goes wrong. But it's not an easy job at Network Ops these days. It's a lot going on.
And when those shows come
Tom's
from
network,
elsewhere,
though, they always one of the networks I worked for, we used to distribute his network, and his guys were really big on customer service. They were really good about that.
Hey, Mark, there was a subject that you touched on earlier in our conversation, and if you don't mind, I'd like to go back to it just because I find it so fascinating. One of the things that AM stations have had to do, as some stations, probably many AM stations, their listenership dwindles. They're looking for ways to maybe sell off a piece of property, maybe consolidate a couple of transmitters together to the same place. And for years and years and years, we as engineers rarely thought of the idea of putting two different or more AM transmitters into the same tower. Because so often the tower was sized just exactly what we needed for a particular frequency, for one frequency from one transmitter. And as an engineer myself, it didn't occur to me that, hey, you know what? We could take that station and this station and put them on the same tower or towers and save real estate, sell off that piece of land that's now maybe more valuable for a shopping mall, or maybe the state wants to buy it to put a road through. And this is a process known as diplexing, when you diplex several, two or more stations into a common antenna system. And Mark, help me understand a little bit about, am I right about the genesis of this idea? I guess it's a lot financial and space oriented, and what stations are doing about this and how they're actually making it work.
I actually do a lot of that. It's kind of unusual for me now these days to work at a site that doesn't have more than one station on it. Mostly because my clients are trying to leverage their existing facilities, adding signals to it. They'll buy signals and consolidate, much like FM stations have done, into community antennas, and just for the economic advantage, I guess you would call it. But with the AMs, especially with directionals, they take a lot of land. And if you've got it and you could figure out a way to get more than one station on it, and get the signals pointing in the right direction and protecting everybody else, it makes perfect sense, because the technology is the same as it's used for FM, except instead of bandpass filters, we use reject filters, so that if you've got two stations, one station's rejecting the other one and vice versa, so they basically disappear with regard to each other. And the other thing that happens, and it's happened with a lot of stations, especially old ones, is that they were built on the outskirts of the city in the 1940s or 1950s, and now all the suburbs are behind them in their nulls. There's an old joke that says, a directional antenna attracts housing developments in the nulls. so and the biggest advertiser, the biggest car dealer in the state always lives in the deepest null.
Yes.
But so I mean, just the act of relocating gives you the opportunity to combine sites and leverage the land. Some are upwards of 30, 40 acres, and the towers and the cost of doing it, because the most of it is once the towers are up, once the transmission lines are trenched in, the rest of it's just equipment. And I've actually built. There's a one array in just outside of St. Cloud, Minnesota, Sauk Rapids. It has 4 stations on it. It's 540, 660, 800, and 1010, and they're all DA2s. They're all Class Bs, and they're all getting along quite happily. But that was a long project, and it was designed that way. But they wanted to add signals, and they just wanted to do it, and that's kind of what it's all about.
Now, all 4 of these stations are not co-owned, obviously.
Yes, they're all owned by the same company.
Oh, they are. Okay. Well, that certainly makes the politics a little easier.
Mm-hmm.
Yeah. Okay.
But,
wow.
I had actually worked. This was a non-directional, but I was out in Honolulu, where land values are just astronomical.
Oh yeah.
So almost every AM tower has at least 3, and 2 of them have 4 on it. The one I was working on was a interference problem between 2 stations, and it's just a matter of fact out there, because nobody can afford to have their own tower.
You probably ran into my friend Byron McCann. No?
You know what? I don't know. It's about 5 years ago, so I'd have to go check my notes. I was more interested with the FCC inspector at that point.
Well, yeah, Byron's involved with engineering in Samoa, in Honolulu. Actually, he's just moved to Samoa, moved back there. But yeah, I had breakfast with Byron McCann probably 8 years ago or so, and we were talking about this diplexing and triplexing of AM stations onto some towers in the Honolulu.
You know what?
area.
Now that you mention, I do think I did meet him out there, because there was one contract service, and then Clear Channel had the other tower that had the 4 stations on it, and we actually for a brief moment we had all the AM stations in Honolulu shut off while we were chasing this thing. So
what'd you call them and say? I guess you had to coordinate that somehow.
Oh yeah, we had everybody there. It's like, okay, well, we'll just, we were at one site, they were and Clear Channel, their engineer was there, and it's like, okay, we'll see if we can make this spur go away. And we started turning them back on until it came back, and that's how we isolated. I mean, there's like 12 AM stations within a couple miles of each other there.
Just curious, can you tell me what you found to fix the spur?
Actually, it was a BE AM6 that actually the spur was actually being generated while it was off. In fact, the signal was actually higher when it was off. The FCC inspector didn't believe me, so we set up 2 FIM 41s, and I said, okay, here it is. Look at it now. Look at mine. We turned the station off, and then the spur went up. The carrier went away. And I actually talked to Jerry Westberg about that. He's the one that designed it. He said, they're very, very efficient mixers. And even when it's off, it's on. And that signal coming in was just enough to mix it, enough to put out about 5 watts of RF into that tower, was enough to be able to hear it on 1810 on an adjacent island where a ham radio operator was complaining about it.
Wow. So what did you
one
fix
trap at the transmitter, and that was it.
One trap. Wow. Amazing. See, I told you those BE transmitters actually reduce spurs when they're on.
You know what? I hate to say it, but I have proof.
Yeah. Wow. Hey, Chris Tarr, you've got a quick follow-up on, or a quick story for us, I think, before we're done.
Yeah, if my internet connection hangs on here, it's kind of crummy. This is actually a site that Mark's familiar with, former site. And I can say the call letters now because it's silent. WKKD in Aurora, Illinois. A company I worked for owned it for about 20 minutes. And the daytime pattern was 180 watts pointed away from Chicago with a huge lobe for 180 watts out to the west. The monitor points were to the east. And I went out to do the monitor points, like we're supposed to. And I stand there with the FIM trying to get something. And I'm not hearing anything. I mean, it is just, there is no signal there. And I'm like, I know the station's on the air. So I walk about 4 feet, and all of a sudden it came up out of the noise, and there it was. But the signal was so weak, because it was already only 180 watts. But then, the signal was so directional away from the east that, your lobes, you could first of all see the tower site from where you were standing, but you had to literally be almost dead on these points. Otherwise, you were completely in the null and you couldn't hear anything. And it was something I had to write a note for the next guy, because it took me. I'm sitting there just scratching my head, trying to calibrate it, trying to figure out the battery's dead, and like I said, about 4 feet forward, and all of a sudden there it was, and got a great signal. But I'll tell you, it's hard to do monitor points at a station that is only putting out 180 watts.
Wow. Huh. Hey, Chris Tobin, you had a follow up, I think, another quick story for us.
Yeah, that was just quick. This is for those of you who have AM directionals or AM daytime onlys, and your nighttime you're shut down and off air. One station I worked at, we were doing some maintenance work on the overnight. We typically do because we're a daytime only, so it's very convenient. Sunset, and you get to work right after that. So do our stuff. Everything is clean, working great. We test the transmitter. Things look just like they should, hunky dory. Leave. Get a phone call on a Sunday morning, right out of bed after I just got back. Hey, we're having a problem. We can't stay on the air, and the readings are all over the place. They're dancing. The needles are moving, blah, blah, blah. I'm like, what? Just 5 hours ago, everything was fine. So I go into the transmitter room, look quickly. Don't smell anything burning, nothing like Bakelite or anything. And I was like, all right, readings on the transmitter definitely look like there's a problem. So whatever it is, it looks like it's at the antenna side. We go out to the towers. First tower we look at, everything looks normal. Second tower we go to, we look at the coils, and one of the coils has what looks like black rings around it. I'm like, that coil wasn't insulated. What is that? It's not a coaxial coil. And we shut down that tower, we go omnidirectional, and sure enough, a snake decided to crawl in and wrap itself around the coil. This is one of the lower RF coils, so it wasn't in the circuit that was the high side of the circuit, so it didn't burn immediately and take us off the air and trip the transmitter. It's slowly cooked. So the erratic readings we were watching was actually the cooking time of the reptile. So we found ourselves with a snake wrapped around the coil. Just, one of those things that happens. You just never know. But it was one of those things. Sunday morning and snake for breakfast.
What's the cooking time of a snake on a lower coil? Oh, jeez. Oh, man. That's great. That's great. Mark, I've enjoyed this terrifically, you being with us. Also, the stories from Chris Tobin and Chris Tarr. I always like these war stories episodes. Mark, if folks want to get hold of you for your engineering expertise, where might they do that?
Usually, you can either send me an email at mark@MuellerBroadcastDesign.com. That's just all one word. Or I'm available by phone most days, unless I'm out in the field, from about 11 till 7 Central Time at 708-352-2166. And that's all. That phone number, contact information is on our website too, which is www.MuellerBroadcastDesign.com. I can't remember my own website. How bad is that? But I'm more than happy to talk with people. A lot of what I do is just, I like people to understand what they've got. I mean, the more people understand how directional antennas work, at least from an operational standpoint, the better off the entire business is, the band is, and we can clean up some of the interference that we all deal with every day.
Amen to that. Cleaning up interference. There's a lot of that on the AM band. A lot from folks with directionals that are supposed to be working and aren't. And I got a suspicion that the owners may have no intention of calling you.
Well, a lot of people just don't understand what's going on. And a lot of times it's a fairly inexpensive fix. And a lot of times it's also costing them coverage. That, if you approach it from that angle, that signal that's not supposed to be going somewhere is being taken from somewhere that it is supposed to be going. And if the signal levels are down in the money market, that's often fixed at the same time.
Gotcha. Well, I'm sure if you got a directional antenna and needs a little help, sure encourage you to call a qualified engineer, and Mark Mueller certainly would be one. Hey, Chris Tobin, thank you for being here with us for This Week in Radio Tech. Appreciate your participation.
You're welcome. Anytime. I had a great time, and those boxes you make, Mark, are excellent.
Thank you.
And Chris Tarr, thank you for being here as well. Appreciate your time and your expertise.
Well, thanks for having me.
All right. Good deal. Hey, and Mark Mueller, thanks again for joining us and taking time out of your day to be with us. We'll hope to have you back again sometime if you wouldn't mind.
Okay. That'd be great.
All righty. Hey, coming up on a future episode of This Week in Radio Tech, I promise you, Mike Durow, inventor of the discriminant audio processor and the Durow, that fancy meter that he invented. That's coming up. I can't tell you when because I don't know, but he did commit to be on the show, and I think he's going to do it sometime in the next 3 weeks or so. We have also, I hope, we got a crazy man engineer going to be on. It's a guy named Tracy Teagarden, and he's an engineer from Las Vegas, and fits the role.
Excellent.
Yeah, Tracy's a good guy, so we're going to see if we can get him on. He said he would, but I'm not, he may have had a beer when he said he would. We'll see. Our show's been brought to you by Axia Audio. Check them out on the web at axiaaudio.com. Thanks a lot to the GFQ Network for making the show possible. We'll see you next week on This Week in Radio Tech. Bye-bye, everybody.
That's all the bandwidth we can pilfer this week. Another TWiRT is propagated, and all the transmitters and audio equipment live happily ever after, thanks to the handsome engineer and his kind, benevolent care. We'll be back next week.
Lord willing and the creek don't rise.
This Week in Radio Tech. Subscribe to iTunes and you'll never miss a show. Search for This Week in Radio Tech in the iTunes Store. Soliciting is strictly encouraged. If you liked today's show, tell a friend. If you didn't like it, we were never here. Kirk Harnack's wardrobe provided by the Salvation Army and the Red Cross Disaster Relief Services. Hair and makeup provided by Penelope Garcia Hernandez Weinberg.
He's unique, wouldn't you say?
I just want to get it over with.
This ends this transmission. Tango, Whiskey, India, Romeo, Tango. Signing off. Okay.